Good evening, everyone. I'm Ashish Ranjan, belongs to HPC Technologies Group within CDAC Pune, and me and my whole team has been involved in developing supercomputer within country, from Param 8000 to our recent Param Rudra series. Our team has been completely dedicated to development of supercomputer in this country, and multiple generation of technological changes we have seen, we have adopted, and now we are gearing towards bigger systems within country. And for that one, we want participation from everybody, mostly from domain people, because if we develop such a large supercomputer and there are not any users, and that doesn't show a good picture about our overall development. So till now, we have been more focused towards capacity systems, means that a system where we can put more applications. But now we would like to have a capability system where a single application can utilize the whole system. So we have identified some applications that can scale to the whole exascale kind of systems. So exascale, when we talk, we talk in terms of mostly accelerated system now, because there has been a virtual, or you can say mental limitation from the HPC world. It has to be done within some few megawatts. But now, because of the AI advent, you can see people are talking about gigawatt of data center. So earlier there was some mental block, but we have to also see how the simulation can benefit, how our applications can take usage of these exascale systems. So I will discussing both technology perspective, system also, and software stack. And I have kept some time for discussion also. For any of the topic, if you want to discuss, I'm here. So just to give a disclaimer and acknowledgement to our NSM. So this whole development recently we have done related to Param Rudra and other technological development are done under NSM. And this NSM has been jointly funded by DST and Ministry of Electronics and Information Technology, MIT. And it has been jointly implemented by IIST Bangalore and CDAC Pune. Not CDAC, basically many centers of CDAC. So it had multiple vision, multiple verticals, and of course, one vertical was that development of supercomputing infrastructure. This mission, NSM 1.0, was more focused towards development of distributed model of supercomputers. So each host shoots or each identifies sites were given some supercomputers, and 60% they can use, and remaining 40% CDAC will allocate to any institute or users across the country. Though we do have some dedicated national facility for 100% access to other users, mostly CDAC has been managing them. Even GMRT has one system that is completely dedicated for their production requirement. But most other systems that we have given to ISC, IITs are basically allocated in a way that 60% they will use, 40% can be allocated to anyone. Major focus of the mission was that we will have indigenous design and manufacturing, R&D for exascale readiness. So you can see when 2018-17 we started this mission, there was no server manufacturing happening in this country. There was no interconnect manufacturing happening in this country. So this mission also enabled that now this NVIDIA interconnect, earlier Mellanox, now getting manufactured in our country. So this is getting manufactured near to Ranjan Gaon only in Javil plant. Then we made, initial mission was that we will assemble the system here, but I think we got lucky. The partner that we selected, they were manufacturing this country. So from the phase 1 itself, we started manufacturing the servers within country. Phase 1 and phase 2 were dedicated to manufacturing with this third-party designs. In phase 3, CDAC developed our own board with our own design. We though took a reference from OEMs, but that was our own design, and we manufactured that server within country. So those the hardware part anyway I will come. So another aspect of this one that we just don't wanted to develop technology and we don't deliver training. So one major vertical was to develop this manpower, so enable them to use the HPC system. So I think this workshop is just also part of that one. So this kind of workshop, like half day, 1 day, even up to 6-month courses has been part of this NSM mission. So as part of this one, we have developed HPC processors. So that part is still going on. We have our on board development Rudra. We have our own interconnect Trinetra. System software stack that we are putting on the supercomputers are completely owned, supported by us. Most of them have been adopted from open source. And this has made all these things to have an ecosystem with this country to catalyze them for this high-end electronics design and manufacturing ecosystem in the country. Now you must have been hearing a lot of buzzword related to this semiconductor development in this country, because that confidence is right now there in this country. Apart from these verticals, we also have one application vertical where we have dedicated, in fact, you can say manpower and money for development of our own applications or our own HPC models. So these were across multiple domains, and we had identified some applications, and those applications have been ported on all our NSM systems. So till now, I think we have given mandate for development of around total 90 petaflop plus of HPC system. This is the cumulative capacity. So out of that one, 37 has been developed and deployed. 10 more are coming. I think few of them have been given approval in the last stage only, and they will come by March. So total 90 petaflop will come by the March 2026. Till now, we have given access to around 12,000 HPC users from around 220 plus institutes, including 1650 plus PhD students. We have also onboarded many startups, MSME institutes also on that one. Job count has been very large across all the systems, though that includes some of the serial jobs also. Till now, we have received around 1,540 publications, but many publications we have not received also. Some of the people who have used our system, they have not given the citation also, so that is a separate issue. Mostly this has been fully utilized system. Some of the systems we have seen wait time is of like 30 days. So those systems are as good as not usable. So that kind of user requirement is there on the systems. And if we cumulatively, for the earlier phase 1, phase 2, if we say, so we have given around 500 crores of worth computational power to the multiple users. So you might have been hearing these multiple Param systems, Param Shivaya, Param Brahma, Param Shakti, and multiple variant. So these were part of the phase 1 and phase 2. So we deployed total 15 systems, including our on Param Siddhi that has been established in Pune itself. So that is a completely GPU system. So I have separate slide for that one. So total 24 petaflop we had deployed as part of phase 1 and phase 2. These are the completely indigenously developed our own boards, and I think one system has been deployed at GMRT, so you can talk to your colleagues here also. Total, this recent 20 petaflops at CTAC Bangalore is still getting commissioned. So if this is done, then I think all deliver for the phase 3 system is done. We have one dedicated system for students. Actually, what is happening to get access, it requires a lot of documentation, approval. So just to delay, just to remove that, we have dedicatedly given one system for this kind of purpose. So if you have training or other kind of requirement for teaching requirement, you can enable your access on this system, and your students can enroll themselves with their institutional email ID. So this is our number one system when it was launched, Param Siddhi, with this 5.26 double precision petaflop. And in AI terms, it was 210 AI petaflop. It was ranked 62 when it was first established. Later on, we established another system, Aravat, of the similar capacity in the adjacent hall. So these two were combined, and it was ranked again number 1, and it was around 8.5 precision, double precision petaflop. And this has a separate user base. Mostly this has been dedicated for AI kind of users, or even those applications that can use only GPUs. For many of you, if you have not access to any NSM systems, getting access is very easy, but you need to provide some documentation. So you can go to nsmindia.in website, and there is a portal. You can self-fill the registration form, and you will receive the further details to proceed further. Coming to the hardware development under this mission, so we have developed our own Rudra series of servers. We have Trinetra HPC network. This network development is very essential for the HPC because characteristics of HPC is very different from many other workload from the cloud and other computing environment. Here we require very low latency, high throughput kind of network, and we have always invested on this low latency network, and Trinetra is the latest series of that interconnect. This system software stack I will discuss separately. We have also developed our own HPC storage. So this is like a high throughput storage, and for the HPC kind of thing where this scratch, where the primary writes happens. So that requires a lot of IOs and throughput. And for that one, we have developed our own storage based on DAOS file system. So DAOS is an open source file system, and it supports only this SSD and NVMe kind of disk. We have our own development of OM processor, and we are also working on developing our own architecture also. OM is basically based on this ARM architecture, so we are getting IP from them, and we will develop our own processor. But RISC-V development will be our own core IP also. So these are 3 variant of Rudra server currently we are offering. First one is the 1U OU. Basically, these are OCP compliant servers, so they are not 1U basically. These are basically, we say 1 OU. And this 1U has 2 servers, each having 2 sockets. And there is another version for this NVIDIA, or basically accelerator kind of platform. So there we can put 4 accelerator in a single server, and those are of around 600 watt to 700 watt. And there is another variant that is basically air-cooled with the independent power supply. So first 2 systems are basically OCP compliant, and OCP rack comes with dedicated bus bar and power supply. So that is a very different kind of system, and if you have fully packed rack, then only you prefer that one. But if you have requirement for 2, 3 or 4 nodes only, then it is always recommended to go with the independent power supply kind of servers. So just to give you a brief of what is this our Rudra SPR platform, these are basically Intel Gen 5 processor based system, dual socket, and it does support DDR5, and it does have 2 OCP NIC for this Mellonix 200 to 400 of speed NIC, and these are completely OCP ORV compliant servers. It comes in 2 form, both air cooled and liquid cooled also. There is another variant of Rudra is now getting developed by our CDAC Bangalore team. This has already been developed. Air cooled version is already available, and now they are working on this liquid cooled version. So this is completely accelerator platform. A single system has 8 AMD GPU OEM form factor, and they have another CPU variant of that one also, and that is of 2U. But if we have more disk requirement, this serves a better purpose. Coming to our processor development, we are developing our own OM processor. This is under the design stage. We have already finalized the design partner. They are developing this processor, and tape out will happen by this December 2026. This is based on chiplet architecture. So within a single processor, we will have 2 chiplets, each of 48 cores, so total 96 core per processor, and a single server with 2 processors. Yeah, please. Pardon? No, actually this core of ARM we have bought from the ARM only. ARM is the IP provider for this core for ARM. So all these mobile phones, everything they are using ARM. So Broadcom is also building the processor. They are buying from ARM. So that core IP chip we have chip for core IP we have taken from them, and now we have found two partners, Moschip and I think Sonaxian. So they are developing that based on our architecture, whatever system level architecture we have defined. So they will develop this processor and tape out will happen.
How do they compare with the Intel or AMD?
So that next slide.
Next slide. Okay.
So this is like overview what this processor is capable of. So these are very much in comparison to any Intel AMD processor you can see. As you can see, this last you can see this is 5 teraflop cumulative power per socket. So this is very in comparison to any of Intel or AMD processor. And it has a large number of PCI lanes, so I can put many accelerators also, and if required, it can be used as a storage nodes also. So this is a picture of Rudra with the liquid cooled system. You can see this instead of air cooled heat sinks, these are DCLC heat sinks are there. So that's why we are able to manage this very small form factor, thin nodes within these racks. And then the right hand side is this completely packed rack with, you can see there are two bars in the center. Those are basically power bus bar. So our servers go and get connected inside back of that one. And left and right side, there are connectors. Basically, those are liquid cooled connectors. So Trinitra is our interconnect, as I said, and these are switchless architecture. So InfiniBand right now, you might have seen your data center or Ethernet. Those are basically with the switch. So you have NIC, then you have a switch. This doesn't require a switch. So it's like a peer-to-peer connection. So it can be connected in a 3D torus topology, and you can make a larger node count with this one. So latest one variant, we have around 10 ports of 200 Gbps on a single card. So I can reach multi-dimension and I can reach high radix through that way. So this is the storage platform that I was mentioning. So this has been developed by our CDAC Trivandrum team, and Rudra platform we are using as a server, but we have a backend controller and bunch of disks attached to that one. And these are completely SSD, NVMe SSD based platform. And I think 4 or 5 nodes can give me around 40 to 80 gigabyte of write throughput. So those were at the component level. Now this is this package system that we are giving Param Savak. So Param Savak is very ideal for those institutes who doesn't have data center, but they want to experiment and develop their own codes, or they want to use as a lab. So this is a ready to use HPC system. You can deploy in your lab. It doesn't require much infrastructure. If a normal AC is also there, this will work. And this comes with the same software stack that we are building in the Param Rudra also. So our smallest system and biggest system, you will find the same software stack. So you can prepare your code, develop your code on this one. And when you are ready with your code, you can run on our bigger system. And we have multiple variant of this Param Savak. We have one HPC variant, then we have machine learning, deep learning variant, then AR, VR variant is also. And we also developed one package solution for, you are seeing me? So package variant for agriculture and bio specific. So that is Param Srishti. So all the package related to bio and agriculture has been bundled in that one. So that was for the initial level. Then there is a Param Vidya system. This is like a mid-range kind of systems where we are making a cluster out of these servers. So if you have minimum 4 to within a rack, 15, 16 racks servers if you want to put, then this is the variant, ready to use variant that you can use. Coming to the software stack, this is the complete software stack. Same software stack we have installed on all our 40 systems. And this has been completely optimized by us. Now this stack is also now containerized so that deployment and management is very easy. If you allow the system, the 3000 nodes can also be get ready within a day. And the right-hand side, all the tools that has been developed by CDAC. So many of the tools that we are getting from open source and community, they are not very customized for my requirement or our requirement. So that's why we have developed those tools with our experience. So this is very specific to our Siddhi, because when we are doing for the AI, there are two different kind of loads are coming. One for the training and one for the inference. Training is still very close to HPC. So our systems were built for the HPC requirement. We had Slum and that kind of environment. AI doesn't require this kind of environment. They are mostly the cloud friendly, and mostly that they should be able to easily do the inferencing with the client access directly from API. But our environment with the multiple firewall and other blocking, that doesn't suit many of the inference requirement. So that's why we have segregated our requirement in Param Siddhi in two ways. So for the training thing, we are using the HPC way of doing things like Slum, PyAxis, that way we are doing. But below down, we have created one cloud kind of infrastructure for inference kind of workload. So now these HPC systems are also not very easy. It's not just you are doing the simulation. You are running some portals also, you are running database also, you are fetching data from online. So all those dedicated services keep on running parallelly to your HPC jobs. So this environment, mixed kind of environment will come into all the HPC systems. So this is the stack. I think Soumya was discussing all this ML deep learning and she was showing on our HPC system. But for this Param Siddhi, we have dedicated only mostly the tools for the GPUs, and this environment is curtailed for AI kind of requirement. Though we have tools like Gromex, NAMD, OpenFOAM also installed on this one. For HPC workload has also been included, but majorly this has been used for the AI kind of workload. So if you go to HPC environment, you have large number of monitoring tools, and they all were made for the general requirement. We found that we have to actually in production environment, we had to use multiple Grafana, Prometheus, even this Ganglia, Nagios, multiple tools we had to use. And those were not very convenient for a single system admin to do. So that's why we developed our own monitoring tool. So that caters most of my requirement, even billing, online monitoring, and from a single site, I can monitor multiple sites also. So this gives me flexibility to monitor all these 40 sites from a single interface also. It easily integrates with Slum, PBS, LSF also. And this, since this is completely developed by our team, so we can do all the customization. So this also gives you reports, billing, each user, what is happening, each job, what is the characteristic, what is happening. So those details, you can get it from this one. So CRAME is another tool that we had developed, and this was, I think, awarded winner of the IDC award in SC 2011. So this is more of like that. Some of the users who are doing the same kind of thing doesn't want to go to terminal. So this is like a interface that will create your Slum or job file. It will create through a web interface, and you just provide your input file, and it will provide. It will give you back your output. So this was it was developed keeping in the mind that some of the users who just only want to do the production run, they can use this interface for just interfacing with this our system without any terminal. This one, we have recently open sourced this project, and I would like some of you to just go and download from and give me the feedback. I will provide you this link for this system, this tool. HPC teaching has been very difficult, and access to the system and running the code. So you might have seen this Kaggle and this Jupyter Notebook environment is very friendly for this cloud kind of one or single GPU. But for HPC kind of setup, when you want to run Slurm, everything, teaching has become very difficult. So this tutor try to cater those kind of segment. So NSM 1 anyway we have executed, and December 2025 is this ending date for this one. Most probably we may get extension a little bit for implementation part. Beyond that, we are going for NSM 2. So NSM 2 will continue our vision of that self-reliance in exascale supercomputing and beyond. And as part of that one, we will develop indigenous exascale ecosystem with innovative design, technologies, and human resource, and along with applications development. So the verticals that I had shown, same will be followed, but this will be much larger scale. And we have got a lot of success. We have got a lot of user base also. Now we have interacted with them individually also. We have identified some applications that can go on our exascale system. And this work is still under progress. This proposal has not been approved, but this still is in the discussion and approval stage itself. And the processor that work we had started, now we would like to make system out of that one. So till I think our project is ending in December 2025, and the step out is happening in December 2026. So we would like to continue this effort, and next mission, NSM 2.0, we would like to have a system based on this OM processor only. We are planning to develop our own core based on RISC, and there is another school of thought that why don't have completely from architecture to IP to everything our own. So that development will also happen. And these all processors will get integrated into our own Rudra server. So we will not restrict ourselves to our own processor. We will also be developing Intel and AMD based servers apart from this one. And we would also like to take a next version of Trinetra series of and software stack. We already have our own, and we would like to scale it for exascale, and whatever development required, we will do. There is another development related to secure grid of moving data to compute, because computes are mostly centralized and users are logging from anywhere in the country. Data movement has been a big problem across the site also. So data generation is happening somewhere else. Moving to supercomputer has been a challenge. So we are planning to come up with a grid kind of solution, so that there will be some edge area within each region. So from there, our supercomputers will be connected over fast network, and data transfer can be happen seamlessly. We are developing our own liquid cooling solution also. So IIT Bombay and CMET has been given some projects. So they are developing their own cold plates and even this dry cooler kind of technologies. So currently with our own assessment, we see that we will have a 200 to 500 petaflop of double precision HPC system by 2027. And we will have exascale system by 2029. Though these seems like a delay, but these are based on completely our own indigenous ecosystem. That's why this will take some time. Otherwise, bought out system, we can do it today also. But our focus is that we will have our own indigenous ecosystem from core architecture to complete ecosystem, and whole system should be our own. So that's it. You can contact me, or for NSM system, you can contact NSM support. And for AI system that I have mentioned, you can contact NPSF outreach at @cdeck.in. Mostly we are very generous in providing access to anyone. Up to 50,000, 1 lakh computing budget access is given free. Beyond that, since these sites are operationally managed by host institutes directly, so they would like to recover some electricity costs. So they may ask, but if your proposal has some merit and you don't have any funding, we will still support. So feel free to drop your requirement on NSM support. Access would not be any issue, but beyond a certain usage, if you can find some computational budget in some other project, that will be great. Thank you. I would more than happy to welcome any question.
I think I have more questions on this Param Sevak, which Can you go ahead?
You go ahead, please.
Okay. The Param Sevak seems to be very attractive for lower end computing. A couple of questions on that. I think how the costs compare with the similar performing and the footprint and any specific cooling requirements this will have.
Your voice is not clearly audible.
The Param
Sevak.
Yeah, Sevak. That costs and also how they are
very costly systems. You will get it within 15 lakhs, something like that. So the cost, we are not taking much on that one. These are basically for proliferation purpose. So these costs are not much.
And the footprint and any specific cooling requirements?
Actually, this was earlier variant when we had this larger form factor. This could have been kept on in desktop also, and this room environment would have been also fine. But now with the Rudra variant, these are a bit more dense. At least room cooling is fine. No special cooling is required. Only you should have the 15 ampere socket. That's it.
Can I ask?
Feel free.
What is the network support, native network support speeds that it comes with? 10 gigabit or?
For Param Sevak, you are saying? Param Sevak is a standalone system. So we are giving 10G port. But if you require a connectivity, but where you will connect? Your LAN itself is 1G or 10G. Unless you want to integrate to Param Sevak, then you require higher bandwidth.
Okay, thank you. Can I go ahead? Okay, two more questions. How is CDAC, the developments place in terms of export market? Are we having any export to other countries?
We do have recently tied up with Brazil. So we are giving our Param Rudra based system to them. In fact, we are planning to give TOT also. So we are open for providing this system. But actually, frankly speaking, we are not very fast to the market. So our design development cycle has been a bit slow because we have a very limited team. Although we are working still the 5th generation, Intel might come up with the 6th generation, and HP Dell might be always faster than that one. But still there are multiple parties who are very interested in this one. And some of these Ghana, other places, we have already given our systems.
No other industry tied up with CDAC?
No, these systems have been developed by our own EMS partner, BVDN and Kens. And we have also given them TOT. So next, we are for the newer system, we are also planning to find a partner. And I think most probably we will try to enable this system on the GEM so anybody can buy directly instead of CDAC being involved in that one.
One different question, I think.
So I'm here for the dinner also. We can discuss.
Yeah. This is the last question. CDAC, I know earlier started with that FPGA-based accelerators.
Yes.
Where are you placed on now?
So I think this accelerator kind of GPU, they are giving so much power and you can do so much with this. So now FPGA kind of development has been now very specific to, if you have very specific kind of problem. And those problems can also be now very much solved in this accelerator if you develop some manpower on that one. So that is now, I think GPUs or accelerator kind of technology are coming so fast with so much computing, and you may or may not require, because FPGA could have given you much specific throughput and low latency for your requirement earlier, because there was only CPU. But GPU kind of thing can solve your many of the problems. But still, financial or many other applications are still using FPGA for their requirement. So they are still relevant.
Okay, thank you.
Thank you.